Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my dear students. My name is Mr. Ahmed Munir, and today, inshallah, we are going to talking about lesson number 2 in Unit 2, the algebraic fractional function. Algebraic fractional. Fractional, as we know it before, in a number we have numerator and denominators. For example, here 1 over 2, 7 over 9, blah blah blah. We have a lot of fraction we can do it, but fractional and function in the same time and algebraic also. That's meaning here, for example, here f of x, that's meaning f of x equal x minus 3 over x plus 2. This is, for example, another example here, f, that's meaning f of x equal x power 2 minus 3 over 5, and blah blah blah. And we know it's impossible to make my denominators equal 0. We can't say 7 over 0, 9 over 0, negative 8 over 0, blah blah blah. We can't say that. Why? Because it's meaningless. Because anything divided by 0 is meaningless. And if you put it in calculator, the answer is going to be math error. And in first prep, when we starting to study the rational numbers, the Q, we said it's impossible to make my denominators equal 0. So we take my denominators here, for example, about the first one here. My denominator is x plus 2. So to find something is called domain. To find what? Domain. The domain of algebraic fractional function is the real numbers. By the way, is going to be all the real numbers except the number make my denominators equal 0. Except the values make my denominators equal what? Equal 0 or undefined. That's meaning what? That's meaning, for example, here about f of x equal x minus 3 over x plus 2. First step here, we use the my denominators. We take my denominators here. X plus 2, we make it equal 0. This is positive 2, we take it the other side to be negative 2. That's meaning x equal negative 2. That's meaning our domain is going to be R, all of real number difference, the set of negative 2. This is the meaning or the referred to domain. The domain here, if we put the x for any number except negative 2, we can get a value. For another example, n of x, n such as n of x equal 3 over 4 minus x. The same things here. It's also use my denominator, 4 minus x equal 0. And this is negative x, we take it to the other side to be positive x. So x equal what? 4. And now our domain is going to be R, all of real numbers except set of 4. Because this is the value to make my denominators equal 0. And if my denominators is going to be equal 0, that's meaning it's math error or meaningless. So in general, to find the domain is going to be R difference the real numbers, all the real numbers except the set of zeros of the denominators. The set of zeros of my denominators. Okay, so now in general, to determine my domain, to determine the domain of any algebraic fractional function, we used our denominators. We put our denominators equal 0, and after that we get the values of x to make this function equals 0. After this, R difference all of this function as the examples we solve it in this part. Okay. Now, what about the set of zeros of algebraic fractional functions? The set of zeros, that's meaning the values to make this algebraic fractional equal 0. For example, here, n such as n of x equal x power 2 plus 3x over x power 2 minus 9. In this part, to find the set of zeros, of the algebraic fractional function, that's meaning now we are going here to use the numerator and denominators, both of them. So the first part, x power 2 plus 3x equals 0. From this one part, we used x as a common factor. So x power 2 divided x equal x plus 3x divided x equal 3. All of those equal 0. After that, we divide this part to two parts. The first part, x may be equal 0, or this bracket, x plus 3 equals 0. Plus 3, we take it to other side to be minus. So x equal negative 3. This is for our numerators. What about denominators? The denominators here is x power 2 minus 9 equal 0. This is negative 9. So also we take it to other side to be positive 9. And x power 2 now equal 9. We get square root for both of them. So x here equal positive or negative 3. But there is a different way to find the set of zeros here. To find the set of zeros of this function n z of n is going to be the zeros of numerators. What about the zeros of the numerators? Yeah, it's 0 and negative 3. Difference the set of zeros of our denominators, 3 and negative 3. So the final answer here, which element, the difference, this difference, that's meaning which element we have it in first set and not in second set. The first set have 0 and negative 3, but the second set 3 and negative 3. So which element in first, not in second? Yeah, that's right. Its only element is 0. So the set of zeros of the function n of x is going to be the set of 0. Let's go to talking about another example here to make sure you get it. If n of x equal 3x plus 6 over x power 2 plus x minus 2. Okay. The same things here. We used our numerators. We put numerators here, 3x plus 6 equal 0. And this is positive 6. We take it to other side to be negative 6. So 3x equal negative 6. This is times. We take it to other side to be divided. So x equal negative 2. What about our denominators here? X power 2 plus x minus 2 equal 0. This is, we can solve it as factorization. X power 2, x and x. The last sign here is negative. So one of them is positive, another one is negative 2. That's meaning 2 times 1 equal 2. And their difference equal 1 here. There is 1, but we didn't put it. So now 2 times 1 and big number with the sign of the middle. Here 2 and here 1. We divide this part. X plus 2 equals 0, or the second bracket x minus 1 equals 0. For the first, this is positive 2, take it to the other side, so x equal negative 2, and here x equal 1. What about now the set of zeros? To find the set of zeros of this function, n is going to be a set of zeros of numerators, set of negative 2, minus the set of zeros of our denominators, negative 2 and 1. It's going to be Which element in first set, not in second? There is no element in first, not in second. So the solution set is going to be what? Is going to be phi. Okay. In this part, we are going to talking about the common domain of two algebraic fractions. Or more, let's go to talking about the first part. If we have two algebraic fractions, for example, here n of x equal 3 over x minus 2, and this is n1, and n2 is going to be n2 of x is going to be f of x over x power 2 minus 1. We need to find here the common domain. Common domain, as we said before, we are going to use our denominators only. So we make x minus 2 equal 0. We take negative 2 to the other side to be positive 2. So x equal 2. Okay, this is the first one. So for the domain of n1 is going to be r difference the set of 2. What about n2? n2 of x is going to be, it's also using our denominators, x power 2 minus 1 equals 0. That's meaning x power 2 equal 1. Equal 1. Now we get a square root for first and second. First root for both of them. So x equal positive or negative 1. And domain equal r difference the set of 1 and the negative 1. What about now to find the common domain? Common domain, it's going to be very, very, very easy. Just the common domain, we put it here. So x equal positive or negative 3. So the domain here equal the set of r difference, the set of 3 and negative 3. Okay, this is for n1 of x. What about n2 of x? The same things, we use our denominators, x power 2 minus 5x plus 6 equal 0. We can use here factorization. X power 2 is x and x. Last sign is positive, so both of them like in the middle. 6 is going to be 2 times 3. And we divide this part to two parts. X minus 2 equals 0. And here x equal 2. Or x minus 3 equals 0. And that's meaning x equal 3. The domain here equal r difference the set of 2 and 3. What about now the common domain? Equal r minus this set 3 and negative 3 and this part 2. Are we going to repeat it again 3? No, because we put it before. So the final answer, the common domain here is going to be 3, negative 3 and 2. This is our lesson today. Thank you for your watching my video. Keep in touch with me. If you have any example, you must be to text me. Assalamu alaikum wa rahmatullahi wa barakatuh.